One more time, we're going to summarize the trends on the periodic table of the elements and decide what they mean. Let's do our hot corners here. Remember, not all the trends apply to the noble gases, so we're going to be talking about our hot corners being fluorine. Make sure this is on your periodic table of the elements notes. And over here at our other hot corner is francium. A lot of times I actually use cesium because francium is not anything we're ever going to run across because he just doesn't hang around all that much. But fluorine in this corner has the ignoring the noble gases, because actually the noble gases have really high ionization energy because they don't want to give up electrons at all because they have full electron shells. But if we're ignoring the noble gases, he has the highest ionization energy. He has the highest electronegativity, and that's even with the noble gases. He has the most metallic character and most non-metallic character and least metallic character. So he's most like a nonmetal. And he is also the smallest. And that's if we're ignoring the noble gases, because helium and hydrogen are actually smaller than him. What this means is it takes the most amount of energy to turn him into the ion. So it takes the most amount of energy to strip a valence electron away from him because he wants to keep his valence electrons. He has the highest ionization energy. That means that he is the best at taking other people's electrons. He is the most like a nonmetal. That means that he is dull, brittle, and he is an insulator, not a conductor. And he's the smallest, meaning he has the smallest atomic radius. So let me show you what that means. Ionization energy is when you take an atom, and the definition is in its gaseous state, you shoot energy at it, and you strip an electron away from him. And that takes the most energy because he doesn't want to be F+, he wants to be F-. So F- would be when he takes an electron away from somebody else to become F-. He is the best at this because he's the bossiest on the periodic table of the elements, so he is the best at taking other people's valence electrons away from them, like such. Let's go to francium down here. He has the lowest ionization energy, meaning he hangs on to his electrons the worst. He loves to give away that last electron. He can't hang on to it at all. He has the lowest electronegativity, meaning that he can't even hang on to his own electrons, much less pull on anybody else's electrons. And he has the least nonmetallic character and the most metallic character. So he's the most like a nonmetal. Most like a metal. And he is the largest. And I'll clarify this electronegativity. He has the lowest electronegativity if you're not counting the noble gases, because the noble gases don't want to pull on other people's electrons. They have no electronegativity. So my story is always the noble gases do not have electronegativity values because they simply don't pull on other people's electrons. So it's kind of like, how fast can Miss Boston run the marathon? Well, There's no value for that because that is never going to happen. So just like there is no value for how long it would take me to do a marathon, there's no value for how well the noble gases can pull on other people's electrons. So let's do ionization energy for francium. That means that I'll shoot some energy at francium, and he will become francium plus 1. This doesn't take very much energy at all because he wants to give this electron away. He doesn't want to hang on to it at all. This is the way he wants to be. He wants to be a francium plus 1 ion. Electronegativity is the ability for him to pull on other people's electrons. So the ability for him to become a francium minus 1 ion. He has almost no ability to do this either. So this is another statement that's not really going to happen. So that's a clarification of all of these trends on the periodic table of the elements one more time. This electron affinity, that's kind of an AP topic. So that's not going to be in honors chemistry. I have that on there because I'm going to next make an AP video, which hopefully some of you will see next year. Hope that clarifies things for you.